Thank you for joining this lesson. We're going to do statistics 1, number 20. The table below shows the marks scored in a chemistry test. Therefore, we have the marks in classes, then the frequencies. The frequencies are the number of students scoring a given range of marks. State the model class. So the model class is the class that has the highest frequency. When we consider the frequencies here, we realize that the class with the highest frequencies is the one with a frequency of 50, that is 35 to 54. So that is our model class. The next thing is to calculate the mean mark. So for us to calculate the mean mark, we have to modify this table and come up with the midpoints, which are otherwise abbreviated X. So we're going to have the midpoints of these classes. So I'm going to have the midpoint for each class, and midpoints are abbreviated X. Then after that, I'll multiply the product of frequency and each X for each class. Then now I get the summations. Therefore, I'm beginning with the first class, whereby I'm having 5 and 14. I add the limits, then I divide by 2. That gives us 9.5. Then times 3, so that I may get f of x. And this gives us 28.5. The next is going to be 15 and 35. 15 and 34, sorry. Then I divide by 2. This gives us 24.5. Then I multiply with the frequency of 19. And this is giving us 465.5. The next one is going to be 35 and 54. Then I divide by 2. This gives us 44.5 as the midpoint. Then I multiply with a frequency of 50. This gives us 22.25. Yes. The next one is 55 and 84. Then I divide by 2. That gives us 69.5. Then I multiply by a frequency of 26. This gives us 1807. 1807. Finally, we have 85 and 94. Divide by 2. This gives us 89.5. Then multiplied by 2. This gives us 179. 179. So the next thing I should do now is to get the summation of f of x, because mean, usually called the mean of x, is going to be the summation of f of x divided by the summation of f. Therefore, I can get the summation of f using the cumulative frequencies. So that I may begin with 3. Then the next one will be 3 plus 19, which gives us 22. The next will be 22 plus 50, which gives us 72. The next will be 72 plus 26, that will be 98. Then finally 98 plus 2, which will be 100. Therefore, the sum of frequencies is going to be 100. Then now we're going to add up f of x, so that we may know the summation of f of x. So the summation is giving us 4705. So when we divide by the summation of f, we're going to get a mean of 47.05. So this is the mean for the given data. The next will be finding the median. So for us to get the median, m, This is usually given by the lower class boundary plus n out of 2 minus cumulative frequency before divided by frequency, then everything is multiplied by W. W is the class length of the median class, cumulative frequency before the median class, then we have the total frequency out of 2, then we have frequency of the median class. This is the lower class boundary of the median class. So what we're going to have here in the substitution, the first thing we'll do is to identify the median class. That is identified by getting the total frequency divided by 2. That gives us 50. Now we go to the cumulative frequency column and we check where the 50th student lie, because that is the median, the 50th student. In the first class, we don't have 50. The second is having a 22. The third, where we have 72, is where the 50th is accommodated. So 35 to 54 is the median class. Therefore, now in the substitution, we will pick the lower boundary for that class. Because the lower limit is 35, then the lower boundary will be 34.5. Therefore, we will substitute here by starting with 34.5 plus n out of 2, that gives us 50, we have already worked it out, minus cumulative frequency before, just before the median class. If this is the median class, then just before the median class, we got a 22. Then out of frequency of this median class. So frequency of the median class is 50. Then we multiply by the class length. Class length is usually obtained by upper boundary minus lower boundary. So we're going to get 54.5 minus 34.5, giving us a boundary, a class length of 20. Therefore, we shall have times 20 in this case. So this is going to be 50 minus 22. Then we divide by 50. Then we multiply by 20. Then we add 34.5. This is going to give us 45.7. 45.7. So that is the median mark for the given data. Finally, we are told to draw a histogram to represent the above information. When class length is uniform, or rather when classes are equal in sizes, for a histogram, we usually plot frequency against boundaries. Frequency against boundaries. When classes are not uniform, like in this case, we usually plot what we call frequency densities against boundaries. Frequency densities against boundaries. So the first case, or the first thing to do here, is to evaluate the frequency density for the data. So frequency density is usually given by frequency out of class length. Therefore, we're going to do the frequency densities of the various classes. So for us to get frequency density, we will need a frequency of 3. 3 divided by, when we have 14.5 minus 4.5, we are getting 10. So 3 out of 10 is 0.3. I'm taking frequencies divided by our class length. Then we will take 19 and we divide by the class length in this case. So 34.5 and 14.5, we have 20. So 19 over 20, class length of 20. So 0.95. 0.95. Remember, these are frequency densities. We are getting frequency divided by the width of the class. In this case, we're going to have 54.5 minus 34.5. That gives us a class width of 20. So 50 divided by 20. 50 out of 20, that will be 2.5. In this case, we shall have 84.5 and 54.5, giving us a class width of 30. So 26 out of 30. That will be 0.87. That is 87. That is to 2 decimal places. Then in this case, we shall have 94.5 and 84.5, a class width of 10. A class width of 10. So 2 out of 10, 0.2. 0.2. Therefore, now that we have frequency densities and we have the max such that obtaining the limits is not an issue, we can now plot frequency densities against class boundaries. Frequency densities against the class boundaries. Therefore, I will get to my grid here. On this axis, I will have frequency densities. Then on the horizontal axis, I'm going to have what we call the limits, or rather the max. The max. Now I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or even 11. And the max are running all the way from 5 to 95. 5 to 95. Therefore, I can use intervals of 10 so that I may accommodate all the data. Intervals of 5, sorry. So that I may accommodate all the data. So from 0, I'll need to have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this is how the classes are going to be. Now that we have the max, we need a scale now for the other axis, whereby I'm from 0.2 all the way to 2.5. Therefore, I can prefer 0.5. So that with the 0.5, I now go to 1.0, 1.5, 2.0, 2.5, 3.0, and such. So the first class is beginning from 5 all the way to 14.5, because they should be the boundaries, all the way to 14.5, all the way to 14.5. Therefore, I'm going to have from 5 just before 5, which is 4.5. So from 4.5, which is this point, up to and including 14.5. So this will be 14, then 0.5, it will be somewhere in that bar. Then the height, which is the frequency density, is going to be 0.3. So if this is 0.5, then 0.3 will be. So this will be the first class, a height of 0.3, then that is the width. The next will be from 14.5 up to 34.5. 34.5. So this will be 34, so that 4.5 will be this point. Then now I will need a height of 0.95. 0.95, 0.9, so 0.95 will be somewhere Yeah, somewhere there, so that I may move now up to this end. Yes, that will be the second class. The next class now will be from 34.5 up to 54.5. So up to 54.5, 54.5 will be somewhere there. Then the height is going to be 2.5. So a height of 2.5 now is going to take us up to this point. That is the third. The fourth is going to be from 54.5 to 84.5, up to 84.5. Then the height is 0.87. So 0.87, 0.87 will be somewhere there, just before 9. That is the fourth. And finally, a height of 0.2 up to 94.5. So up to 94.5 will be somewhere at this point. A height of 0.2. A height of 0.2. So the height 0.2, then this is the length. So these are the bars which are representing the histogram for the given data. Thank you for following. Subscribe and share.